The first thing we want to do when we look at a regression problem is actually view the data, graph it out. And so we're going to do this in SPSS. We're going to use the longitudinal vision database. And we're going to look at myopia patients. We're going to split by ethnicity. And we're going to look at refractive error regressed on init years. So let's go to the graphs. Use the legacy. Kind of an old school guy. There are other options here, but I just stay with the old because it's just easier for me. We'll go to define, and let's look at years before and after myopia as init years. That's the x-axis. And refractive error will be on the y-axis. And let's take a look and see what we have. Now, SPSS does not give publication quality graphs. They're actually pretty ugly. And you can work, there are options to work on making it look a little bit better, but it's a struggle to make a really high quality publication graph with SPSS. Excel is a much better option, or another graphics package. Now, there's a lot of points. This is ethnic Asian. We can see we have African American, Caucasian, Hispanic, and they all have a similar shape. We can see it's a linear relationship. That's what we were looking for. We graph to look for outliers, so that's kind of not a particularly good point. We also, in regression, the assumption is that it's linear. Well, you can see this kind of linear. It goes down, but it has this little curve at the top here, which kind of violates the assumption of linearity. The other assumption is that the errors are normally distributed around the line. It's actually kind of hard to tell that because all these points are kind of sitting on top of each other. You can't really explain very much. Anytime you have a fairly discrete variable, and these are years, things tend to block up a little bit. So in a data set this size, it's often better, rather than to do a scatter plot, it might be better to come in and do a box plot. So we have a variety of choices here, but box plot is going to probably work for us better. We'll try a simple box plot. And do this again. I'll show you why. Did this previously, and summaries of separate variables was chosen. The default is summaries for groups of cases, which is probably what you're going to usually want. And we're going to look at refractive error. On years before and after myopia. And it gives us the frequencies. You can see here we are at -7 and 6 years and 5 and 6 years. We don't have very many values even at 5 years. It's kind of questionable as to whether to include those in our graph or not. This is what a box plot looks like. The boxes represent 50% of the cases. Remember these first three, there was 7 cases here and only a few here. So the boxes represent 50% of the cases. 25% are below this line, and 25% are above this line. When there are no little indications of these numbers, these outliers, the bottom and top stem refers to the min and max values for that. If you're outside this, then if there is one, like an observation right here, this line is defined by the length of this box. Kind of a confusing, arbitrary system. But this little circle is more than a box width out. This star right here is more than 3 box lengths out. The numbers that we see here represent the line number in the data file. So 367 is number 367. It's not the ID, but line number 367. Go down a little fast. 367. Right there. It's -5 with a refractive error. Refractive error 367 1.30. Look at that. See, that's about right. You can make some edits to this graph by double-clicking on the graph itself. And for example, if you don't like the gray background here, you can click on fill and say nothing, and then you have to hit apply. Let's look at these little observations here, and actually we don't want to use them, so kind of get in the way. We can hide the data labels. That gets rid of those. It looks a lot prettier. So graphing in SPSS is very easy, though it doesn't show a very publication quality chart. But there are lots of options that you can do to add things. For example, you can, if we want to see, add a vertical line. This one happened to come in at 0, our reference line. We could also add a horizontal vertical, and it's set at -3. We could make it a 0 and bring it up there. So this is the 0 point for refractive error. You can see that myopes go below 0 at least 1 year before